In this problem, we are trying to solve this equation and find all of the values for x in radians where it equals 0.6. So right away, I can't solve this equation as it is right now. But if I notice the pattern, sine of an angle, cosine of an angle, cosine of the first, sine of the second, and we're subtracting, we can look at our identities to find a way to rewrite it. And so here is that similar pattern, sine of an angle, cosine of an angle, cosine of first, sine of the second, and we're subtracting. And so instead of having this all expanded out, I can rewrite this as the sine of this first angle minus the second angle, 0.9. And again, we're looking for where that equals 0.6. Now that we have this in terms of a singular trig function, we can solve the equation for values of x. Before I do that, I'm going to look at the graph to see how many answers we should have. So here is the curve of the second side here, the sinusoid, and then over on the other side is y equals 0.6. So I'm looking for a value, it looks a little less than pi over 2. I'm looking for another value a little bit past pi. And in between 0 and 2 pi, I can see I'm only going to have two different answers. So going back to what we know about solving trigonometric equations, I'm looking for where sine is a positive ratio, and that will be in the first and the second quadrant. With your calculator in radian mode, we'll take the sine inverse of the ratio 0.6, and we will end up getting the angle 0.6435. To find the second angle, we can see that it puts us in the second quadrant, and so we know that this answer will also be 0.6435, so we'll take pi minus that to get the second unique solution. Make sure you use the pi button and the entire answer that's in your calculator. And so my other angle will be this 2.498. And so I need to find values of x that would give us these angles. And I'm going to take x and subtract 0.9. So I'm going to do the exact opposite of that. And I'm going to need to add this 0.9 to both of these angles that we found. So I'm going to set the inside equal to the 0.6435. And then the other answer that we just found, the pi minus, which is 2.498. And we're going to add 0.9 to each of those answers. So when I add 0.9 to the 2.4, I end up getting 3.398, which seems reasonable since we needed an answer past pi. And then my other answer, I'm going to arrow up and grab the 0.6435 plus 0.9. And the other answer is roughly 1.544. Again, we found our only two answers. They seem reasonable for where they needed to be on the graph, and so we're done.